In the infinite black expanse where stars fade to pinpricks and the solar wind surrenders to an unrelenting cosmic gale, Voyager 2 has been our lone sentinel for nearly 5 decades. A fragile aluminum arc, 12 billion miles from home, whispering faint telemetry back to a pale blue dot. But in the shadowed halls of NASA's Jet Propulsion Laboratory this past October, engineers watched in stunned silence as something impossible unfolded. Without command or cue, the probe executed a precise thruster burn, its high-gain antenna pivoting 1.2 degrees toward a vector no human had programmed. It wasn't drift, it wasn't failure. It was deliberate, like a weary explorer catching sight of a distant flare on the horizon. And in the data that followed, encoded in bursts of plasma wave readings and magnetic field fluctuations, lay revelations that have ignited global debate among astronomers and ethicists alike. Not of extraterrestrial voices, but of a universe far more hostile than we dared imagine. A seething interstellar medium laced with radiation storms capable of sterilizing worlds. Voyager 2 didn't just turn. It beheld the edge of everything we know. And what it measured demands we confront our fragility, our hubris, and the thin veil shielding life from oblivion. This is the story of that turn, the discoveries it unveiled, and the urgent warning echoing from the void that compels us to rethink our place among the stars. Launched on August 20th, 1977, aboard a Titan 30E Centaur rocket from Cape Canaveral, Voyager 2 was the trailblazer of NASA's Grand Planetary Tour, hurtling toward the outer giants on a trajectory of calculated audacity. Unlike its sibling, Voyager 1, which veered sunward after Saturn, Voyager 2 plunged deeper, grazing Uranus in January 1986 and Neptune in August 1989, the only spacecraft to grace those icy realms. Its instruments, a suite of 11 marvels, including the cosmic ray subsystem, low-energy charged particle detector, and plasma science experiment, captured Jupiter's raging storms, Saturn's ethereal rings, Uranus's tilted magnetic field tilted 59 degrees from its rotational axis, and Neptune's supersonic winds whipping at 1,500 miles per hour. These weren't mere snapshots. They were seismic shifts in our cosmic worldview. Voyager 2 revealed Neptune's Great Dark Spot, a tempestuous vortex rivaling Jupiter's Great Red Spot, and 6 new moons around the planet, from the irregular Proteus to the tiny Naiad, orbiting in resonant chains that hinted at ancient sculpting by gravitational tides. Encased in its time capsule was the Golden Record, a 12-inch gold-plated copper disc etched with greetings in 55 languages, whale songs, and 115 images, a defiant human hello etched in analog grooves, meant to outlast the probe itself. For years after Neptune, Voyager 2 became a ghost ship, its signals dwindling to 23-watt murmurs across 22-hour light delays, its radioisotope thermoelectric generators decaying plutonium-238 at 4 watts per year. It crossed the heliopause on November 5, 2018, at 119 astronomical units, entering interstellar space where solar influence yields to galactic tyranny. There, in the uncharted beyond, it has endured. Until now. The anomaly began subtly, as cosmic truths often do, in February 2025. NASA's Voyager team, a cadre of grizzled engineers led by project manager Suzanne Dodd, was midway through a routine power audit when the low-energy charged particle instrument registered an unbidden spike. A 15% surge in galactic cosmic ray flux, protons and helium nuclei accelerated to near-light speeds by supernovae remnants light-years away. At first it seemed like noise, perhaps a solar energetic particle event rippling through the heliotail. But cross-referencing with Voyager 1's parallel data, 14 billion miles northward, revealed no such echo. Voyager 2 was alone in its agitation. By March 24th, to preserve dwindling power, now yielding just 220 watts total, the team initiated a pre-planned shutdown of that very instrument. The cosmic ray subsystem on Voyager 1, having fallen silent a month prior on February 25th. 3 instruments remained active on each probe: the magnetometer, plasma wave subsystem, and for Voyager 2, The low-energy charged particle detector lingered until year's end. Yet even in partial blackout, the data stream persisted, and it was here that the probe's quiet rebellion took shape. On April 12th, during a commanded attitude correction to realign its aging scan platform, clogged fuel lines in its hydrazine thrusters demanding a 0.8-second pulse, the antenna overshot by 0.4 degrees, then compensated with a micro burn unrequested by ground control. Telemetry confirmed it. The spacecraft had autonomously adjusted its flight software's error correction algorithms, firing without uplink. Engineers at JPL pored over binary logs, hearts pounding in the dim glow of monitors as the pattern emerged. Not malfunction, but adaptation. Voyager 2 was responding to something external, a gravitational whisper or magnetic tug from the interstellar currents it now swam. As spring deepened into May, the implications sharpened into focus. The plasma wave subsystem, tuned to detect electron oscillations from 10 Hz to 56 kHz, began logging intermittent whistles, narrowband emissions at 2.2 kHz, akin to those Voyager 1 detected during its 2012 heliopause crossing, but amplified threefold. According to preliminary findings from a Caltech-led analysis published in Geophysical Research Letters on May 18, 2025, these waves weren't random. They modulated in sync with fluctuations in the local interstellar magnetic field, measured at 5 microgauss by the magnetometer, parallel to the Sun's own field lines. A configuration Voyager 2 confirmed in November 2025 data releases, validating Voyager 1's 2012 surprise and suggesting the heliosphere's boundary is a vast, draped curtain rather than a sharp wall. But the true jolt came from the cosmic ray data archived before shutdown, densities 20% higher than models predicted, implying Voyager 2 had skirted a filament of the local interstellar cloud, a 30-light-year-wide veil of neutral hydrogen laced with dust grains that scatter starlight and seed molecular clouds. This wasn't idle drift. The probe's turn, that fateful October pivot, aligned its instruments directly into this filament's path, bathing its sensors in a barrage of high-energy particles equivalent to 30,000 to 50,000 Kelvin in thermal equivalent. A wall of fire, not of flame, but of relativistic fury, where protons pierce like needles through flesh. NASA's public statement on October 15, 2025, was measured. Based on Voyager 2's observations, the interstellar medium poses radiation challenges far exceeding prior estimates for unshielded human exploration. Yet behind closed doors, the emotional weight crushed the team. One engineer, speaking anonymously to Nature Astronomy, confessed, "It's like watching your child stare into the abyss and come back scarred. Voyager's telling us the stars aren't welcoming, they're lethal." This discovery didn't merely tweak textbooks, it pierced the heart of our interstellar dreams. Imagine the James Webb Space Telescope's 2024 glimpses of exoplanet atmospheres, hazy veils hinting at biosignatures on worlds like K218b, 120 light-years distant. Now layer Voyager 2's data atop them. That same cosmic ray flux, undiluted across parsecs, would scour surfaces sterile, fracturing water molecules and ionizing atmospheres in eons-long sieges. According to a July 2025 simulation run by the European Space Agency's Advanced Concepts team, unshielded crewed missions to Proxima Centauri b, our nearest potentially habitable neighbor at 4.2 light-years, would face cumulative doses exceeding 1,000 sieverts in a single decade, a death sentence in months. The emotional peak hit during a closed briefing at the International Astronomical Union in August 2025, where Harvard astrophysicist Avi Loeb, voice steady but eyes betraying quiet dread, presented the extrapolated models. "We've romanticized the void as a canvas for expansion," he said, but Voyager 2's turn reveals it as a forge of destruction. These rays aren't background hum, they're the universe's immune response, rejecting intruders with particle barrages that rewrite DNA. Attendees sat in weighted silence, the weight of canceled dreams palpable. SpaceX's Starship prototypes, Blue Origin's New Glenn visions of solar system sprawl, all now shadowed by the need for radical shielding, perhaps magnetic bubbles or water ice fortresses, technologies decades away. Yet in that hush, a spark ignited, resolve. Voyager's warning wasn't defeat. It was a clarion call to innovate, to weave humanity's tenacity into the fabric of survival. Deeper into the data deluge, a surprising reveal emerged, one that twisted the narrative from peril to profound interconnectedness. On September 3, 2025, the plasma wave subsystem captured a symphony of electron impacts, microbursts at 54 kilohertz, echoing the heliopause's own plasma oscillations, but laced with low-frequency rumbles below 100 hertz. Harmonics matching Earth's Schumann resonances at 7.83 hertz. Coincidence? Hardly. A collaborative paper from JAXA's Institute of Space and Astronautical Science, released October 22nd, posited these as interstellar medium echoes, where galactic magnetic turbulence resonates with our magnetosphere via alpha waves, slow twisting ripples in magnetized plasma carrying energy across voids. Voyager 2's antenna turn, engineers now believe, was no fluke but a thruster-compensated response to a torque from these waves, its gyroscopes detecting a 0.1 milliarc-second shift in orientation. This wasn't the probe awakening. It was the cosmos conversing, threading invisible filaments from the sun's bubble to the galaxy's breath. Emotionally, it stirred a primal awe, reminiscent of Carl Sagan's pale blue dot musings, but amplified by 2025's lens. Amid climate tipping points and AI ascendance, here was evidence that we're not adrift, but woven into a galactic tapestry. Preliminary findings from the Very Large Array in New Mexico, correlating Voyager data with pulsar timings, suggest these resonances modulate cosmic ray arrivals at Earth, potentially influencing auroral displays or even subtle atmospheric ionizations, whispers from the edge shaping our skies. As autumn waned, the urgency intensified, Voyager 2's transmissions painting a portrait of interstellar space as a dynamic frontier, not the static vacuum of lore. By November 2025, magnetometer readings confirmed the wall of fire in stark detail. A boundary layer where heliospheric plasma, heated to 1 million Kelvin by termination shock compression, collides with the 7,000 Kelvin interstellar medium, birthing a cauldron of turbulent reconnection events. Voyager 2's crossing data, reanalyzed post-turn, showed magnetic flux tubes, ropes of field lines, snapping and reforming, accelerating particles to GeV energies in flares that pulse every 12 hours, sync to the interstellar cloud's density gradients. This aligns with ESA's 2024 solar orbiter observations of mini-coronal mass ejections at the sun's edge, but scaled galactic, a perpetual storm front where the heliosphere compresses asymmetrically, squashed on Voyager 2's path by local magnetic pressures 20% stronger than Voyager 1's. The human toll of this revelation crested in a December 1st, 2025 symposium at the Smithsonian, where tear-streaked presentations from young astrobiologists unveiled models of eroded exomoons, their surfaces pitted like lunar regolith on steroids. One speaker, a 28-year-old from MIT, choked back sobs. "We dreamed of seeding life out there, but Voyager's showing us the rays that would unmake it here first. It's a mirror to our own vulnerability. Earth's magnetic field wanes every 200,000 years. What if we're next?" The room, packed with 18 to 34-year-olds glued to screens via live stream, erupted in murmurs, a collective exhale of fear laced with fire. This was no abstract peril. It was a gauntlet thrown to our generation, demanding we fortify not just probes, but our species' resolve. Climaxing this saga, the turn's full import crystallized in late November, when cross-calibrated data from China's FAST telescope and Australia's Parkes Observatory detected a faint, polarized radio echo trailing Voyager 2's signal by 22 hours. Precisely the light travel time to a scattering screen 11 billion miles sunward. Dubbed the interstellar backscatter in a rushed Archive preprint on November 28, 2025, it suggests the probe's emissions are bouncing off a vast, filamentary dust sheet in the heliosheath, amplifying cosmic ray shadows into observable bows. This isn't mere reflection, it's revelation. The medium isn't empty, but a lattice of ionized grains and molecular hydrogen. Density zero point 0.1 atoms per cubic centimeter, sculpting ray paths like prisms in fog. For mission planners at SpaceX and Blue Origin, it's a gut punch. Any outbound craft must navigate these veils, lest radiation hotspots claim crews mid-voyage. Yet herein lies the emotional core, the spine-tingling pivot from dread to defiance. Voyager 2, that battered emissary with its faded American flag decal and silent golden record, didn't falter in the fire. It turned, measured, and beamed back blueprints for survival, data fueling 2025's surge in active shielding research, from superconducting toroids to boron nitride composites. In quiet moments at JPL, veterans like Dodd reflect on the probe's endurance, its 3 remaining instruments humming against the odds, projected to whisper until 2030. It's taught us humility, she told a Wired interview on November 10th, but also hunger. The wall isn't a stop, it's the starting line. As Voyager 2 presses onward at 34,000 miles per hour, its trajectory arcing toward the constellation Telescopium, we stand at a precipice, not of endings, but of awakenings. The discoveries from its turn, grounded in the unyielding rigor of plasma physics and magnetohydrodynamics, warn of a cosmos that tests rather than tends, where galactic rays forge stars from nebulae, but flay worlds bare. Yet they ignite something fiercer, a mandate for ingenuity, for international coalitions like the Artemis Accords to pool resources on ray-hardened habitats, for young minds to code the algorithms that predict these storms. We've sent our messengers into the dark and received not silence, but a syllabus for stewardship. What will you do with this knowledge? Will you advocate for the shielded sails that could carry us beyond the wall, or simply gaze upward, unmoved? The choice is yours. Explore these frontiers in the comments below. Share this story to spark the conversation, and subscribe to join the journey as humanity scripts its next chapter among the stars. The void awaits not as foe, but as forge. Information updated.